Hello. Hello, everyone. I'm going to wait until the number of concurrent viewers is 30, and then I'll get started. Hi, Hazel. Hazel, come here. Come here. Oh, Hazel. Good morning, everyone. Waiting until the number of concurrent viewers is 30 people. What you do? 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 Gonna wait a few minutes past when the class starts because just because it's the first day. Hello? Waiting for the number of concurrent viewers to go above 30. So every day, this is where I will be. Got about 10 people left. Yeah. Yeah. Hello. Five more people and then I will begin. Good question. Are we going to use Zoom at all? The answer is yes. That'll just be after my YouTube lesson. So I'm recording on YouTube so that I can immediately post it for people to rewatch if they need to. Gonna wait about one more minute before I get started. Okay. If you know someone who's in the class and they're not watching the YouTube live, send them a text message. Oh, there we go. We got a few more people coming in. All right. Well, I think I'm going to start. So I wanted to begin with a few announcements. So first of all, I wanted to remind you to click on the daily attendance button in Canvas and submit your student ID. And that is how I will take your attendance for today. Today's lesson is going to take about 35 minutes or so. And so immediately following my YouTube broadcast, I will open up the Zoom room. And so we'll all go there, and we're going to work on the daily assignment together. Okay. So that's immediately following my broadcast. We have office hours today from, I believe it's 1:30 to 2:30. So if for some reason you don't finish the daily quiz today or during the class period, you can come to my office hours. So it's just the same Zoom room. I'll just be sitting in my Zoom room, and you can ask me questions if you have them. All right. I am monitoring the live chat, so if you have any questions at all, just type them into the live chat. There is about a 20-second delay between what you're seeing and what I'm actually when I'm saying it. So just keep that in mind. It might take me, 20 or 30 seconds to actually get to your question. So first of all, I guess I just wanted to talk about what is physics a little bit. So first of all, physics is the most fundamental science that you can take in high school. Okay, so physics is the basis for all of chemistry. So everything you learned in chemistry has physics at its most fundamental level. And also even in biology has physics underneath it. So it's the most fundamental science. If you want to understand something at the most detailed level possible, you have to understand it in terms of physics. So what is physics? It's essentially a predictive model of the universe. Okay, so and so if we set up some experiment, the laws of physics are going to be able to predict the outcome of that experiment. Okay, so that's what we're going to learn. We're going to learn sort of the rules of how to predict the outcome of experiments. So I'm going to switch over to my document camera. So this is how I'm going to sort of deliver my lessons. I've got my document camera sitting on my desk here, and I'm just going to write the lesson onto this piece of paper. The reason I'm doing that as opposed to a fancy PowerPoint is just that we'll be using a lot of equations. We'll be dealing with numbers a lot, and it's just difficult to typeset all of that, so it's just easier for me to write it. Please let me know if the resolution is too bad and you can't see what I'm writing. I'll try to write fairly large. I would recommend, as you're watching my lessons, to take notes. That being said, I'm not going to require it. It's just you do what is helpful to you. I would also recommend that you have a calculator nearby, so if there, you can follow along with my calculations. Good. I'm glad the size at the top of the page is good. And then if for some reason you missed this lesson, it'll basically be public on the internet immediately following the broadcast. Okay, so I have it set so that it just automatically uploads. Okay, so I'm going to go ahead and start with physics. So the way that the class works is it starts out really basic. So probably for today's lesson, you're going to be like, my gosh, this is really simple. And it's sort of that way by design. I just want to gradually work up the level of difficulty. So what we're going to talk about first today is something called position. Okay. So position is a number representing where you are or where something is with respect to an origin. So the origin basically defines where is position 0, okay? Where is position 0? So the origin sets up our coordinate system. We would set the origin wherever is convenient. Uh-oh. All right, I think I'm back. I apologize for that. Sometimes my internet cuts out. It shouldn't happen too often, but it will happen sometimes. Hey, thanks for the likes. I got 5 likes. So we're measuring the position with respect to an origin, okay? So the origin defines position 0. It could be, if we were in a classroom, we would decide for the origin to be in the classroom. Position 0 would be in the classroom. If you were an astronomer studying the solar system, an astronomer studying the solar system would put the origin at the location of the sun, because as you know, the sun is kind of the center of the solar system. If you were a cosmologist studying the entire universe, you might put the origin of the coordinate system at the location of our galaxy, which is called the Milky Way. So the origin is important, all right? We're going to denote the position by x, and so I want you to think about it as a number line. So here's the position, and somewhere is the origin, and wherever you are, there's a question, should we be taking notes? If you want to, if that's your style, I'm not going to require you to take notes, but I would probably recommend it. So maybe this is over here at position position 5 or something like that. I will put a square bracket around x like this, and that means units of position. Units, so anytime there's a square bracket, that means units of, all right? So what do you think that this means if I put square brackets around t? Go ahead and type it into the chat if you think you know what that means. Or what is, yeah. Units are incredibly important. We're going to be using the metric system, so our unit of position is going to be the meter, okay? So I will put a parentheses m to show that I'm measuring position in meters. Correct, yeah, the T in the brackets means units of time, and our unit of time is going to be seconds. That's the metric unit of time. So just the variable t is time, but if it has the square brackets around it, that's units of time. Let me give you an example of units being incredibly important, okay? There's a Mars probe that was set to land on Mars. It's landing on Mars, all right? And there are different groups of people who are working on this Mars probe, okay? And so one of the things that the Mars probe has to do is it has to measure how far away from the ground it is. And when it's a certain distance away from the ground, it fires its thrusters to slow to a stop and then gently touch the ground, okay? Now it turns out that the team that was programming the radar data for how far it is above the ground were programming that the distance above the ground in feet, okay? And the people who were programming the thrusters on the probe thought that that distance was measured in meters, okay? So they wrote the code to say, when the probe is 10 meters above the ground, fire the thrusters and slow down to do a gentle landing. But the data that they were getting was actually in feet. So what the probe actually did was it fired the thrusters 10 feet above the ground. So just for comparison, if this is 10 feet above the ground, this would be 10 meters above the ground. So the probe was a lot closer to the ground than they expected it to be when the thrusters fired, and it wasn't able to slow down in time, and so it crashed, and millions of dollars were wasted, just because they didn't communicate with each other about units. So that's a classic example of why units are important. If we were dealing with motion that's not only along the x direction, but it could also be along the y direction, the vertical direction, we might include a y coordinate. Or if they're moving in 3 dimensions where they're going into the page and out of the page, that would be a z direction, so that we're not limited to just x representing position. It could be y or z also. All right. Okay. So I'm going to introduce another symbol, or a new concept. It's called the displacement. Okay. And the displacement is denoted by delta x. Okay. This is the Greek letter delta. We have a rare Ivan sighting. See Ivan? Rare Ivan sighting. Hey, Ivan. It's eating. And so delta x, also known as the displacement, means change in position. Okay? And so what it's equal to is your final position minus your initial position. So one of the things we do in physics is we use subscripts to give us more information about a variable, okay? So this is your final position. All right? That's what the F stands for, is final. So where you ended up. So if you go to your friend's house, your final position is going to be the position of your friend's house. The 0 as a subscript means initial position. Okay? So that's what that means. The 0 stands for time 0. Okay, so I'll say initial position, x. Another way of saying that is x naught. Some other subscripts that we might use, we might say x1 and x2. So that would be position of particle 1, position of particle 2. If you're tracking more than one thing, maybe 2 planets. This is completely general. So it also makes sense to say delta t, or even delta m. So why don't you type in to the live chat what you think delta t is going to be equal to, or how would you say it, and what is delta m? So I'll think about that. So let's just do a really quick example here. So what if we're looking at this person? Very good. Yeah, delta t is change in time. And so that would be t final minus t initial. And delta m is actually change in mass. So we kind of use m in 2 places in physics. It's change in. So m can represent meters, or it could represent mass, and in this case it's representing mass. So that would be mass final minus mass initial. That's used in rocketry a lot, because as a rocket is leaving the atmosphere, it's spending all its fuel, so its mass is changing. So these are some examples of using the delta. Okay, so let's look at this person who's at position 5 meters. Okay, and what if they walk over to here at position -1 meter? That's a negative position because it's to the left of the origin. So what is the size of that displacement? Well, their final position is here at -1. Okay, so I'm going to put in -1. Their initial position is here at 5. So I'm going to put in 5 for x naught. Keep in mind, if your initial position is negative, you're going to have a double negative, which is going to become a positive. But in this case, the initial position was positive. And so I get -6 meters is the displacement, okay, for this person. I want to distinguish between having a position of -6, being located at -6 meters, and having a displacement of -6 meters. Those are two different things. What would it mean to have a position of -6 meters? Well, that would be 1, 2, 3, 4, 5, 6. This would be -6 meters right over here. So if your position is -6 meters, it means you're located over here. Having a displacement of -6 meters means you moved 6 meters relative to where you started. Okay? So this is a displacement of -6 meters. Okay? I'm going to pause for a moment because I want you to think about what is the significance of this minus sign. Go ahead and type it into the chat if you think you know what that minus sign represents. Okay. This is a good way for me to actually measure what the delay is. I wish I was actually measuring it. Excellent. So yeah, the sign, excellent. The sign of the displacement is indicating the direction of travel. So if the displacement is negative, that means you moved in the negative direction, which in this case is to the left, okay? If the displacement is positive, you moved in the positive direction, which in this case is to the right. If we were talking about displacements in the vertical direction, then in the vertical direction, like y, then a positive displacement in the y direction would mean you went up, and a negative displacement means you went down, okay? All right, so speaking of that, let's talk about displacements. In 2 dimensions. So this was a oh, there's a question, what if it were 3D? Then a positive displacement would be a positive displacement in the z direction would be out towards you, and a negative displacement would be in away from you. Okay. Okay. So this is one dimensional, right? You're only going forward and backwards. What if we had 2 dimensions? Okay. So maybe in 2 dimensions you start out right here. I'll put a 0 there for initial position. And you end up over here. This is your final position. And to get there, you go along this curly path like that. Okay? So that's a two-dimensional displacement. Now, the size of the two-dimensional displacement would be the length of that line. Okay? So this is the size of the displacement. Notice that the size of the displacement does not care about the distance traveled along this curly path. All that the displacement cares about is where did you start and where did you end. Okay? This curly line, the length of that curly line, is called the distance traveled. The distance traveled is kind of like what the odometer would read on a car. Okay? So, if you go from here to here, but you go along this path, then the distance traveled is going to be greater than the size of the displacement, because this line is longer than the direct line. Okay? So just to make sure you understand, let's suppose I have a number line, position measured in meters, and let's put the origin right here. And what if you undergo a displacement of 13 meters plus 13, and then you undergo a displacement of minus 10 meters. Okay? So you undergo two displacements in a row. Two steps. There's two steps in this journey. What is the total displacement and what is the total distance traveled? So I'm going to give you a second to think about that. There's a question of, does this class go hand in hand with AP Calculus? I don't use any calculus in this class. I might reference it, but calculus is never ever going to be required. This is an algebra-based class, so we will use algebra, but no calculus. If you take a second-year physics class, we do calculus the following year in the physics class. All right? So I'm waiting for someone to tell me the size of the total displacement and the size of the total distance traveled. Cool. All right, so very good. I'm seeing a lot of good answers. So if we look at it, this distance to that, you can figure out that you would end up at position 3 meters. So that distance right there is 3 meters. So I'm going to put the displacement of plus 3 meters. Why did I put the plus? It's because it is 3 meters away from my starting point in the positive direction. Okay? The distance traveled would be like what an odometer in your car would read. All right? Which would be 13 going forward, and then it would get an additional 10 meters going backwards. So that would be 23 meters is the total distance. Excellent. Okay. So that's displacement. Next thing we're going to talk about today, this is the last thing, so there may be 5 or 10 minutes left in my lesson, is velocity. Okay, velocity is the rate. Oh, we have a question here. In 3D, what dictates the direction of the displacement? So in 3 dimensions, the displacement is going to be 3 numbers, 3 separate numbers. One number for how far you go horizontally, one number for how far you go vertically, and one number for how far you go in and out of the page. All right. And then the size of the displacement, you kind of just do the Pythagorean theorem. But we're going to primarily deal with one-dimensional motion in this class. So just back and forth along the x-axis. So the velocity is the rate of change of position. Okay? You could also think about it as speed with direction. Okay? You got to be careful. Speed and velocity in physics are two different things. Speed is only how fast you're going. Velocity is how fast you're going and the direction of travel. So, for example, if I had maybe 50 miles per hour east and 50 miles per hour west, those represent the same speed because they're both 50 miles per hour, but the 50 miles per hour are headed in opposite directions, right? So this is different velocity. Okay? So that's how that works. I will give you a formula, a mathematical formula for velocity. V, velocity is represented by V, and it is displacement over time elapsed. Perhaps. I would prefer it if you screenshot the video or something like that. That would be a lot easier. So this is the definition of velocity. So I'm going to wait maybe 20 seconds, and I want someone to tell me what they think this is equal to. Okay? If you're taking notes, look back to what that notation means. Another thing I want to talk about just while you're thinking about the answer to that question is there are deltas here. Yes, it means units of velocity. And what do you think the metric units of velocity are? Excellent. They are meters per second. Okay? Meters per second. So miles per hour are the units of velocity, but they're not the metric units of velocity, so we'll be using exclusively meters per second. All right? What was I going to talk about? Oh, yeah. The delta symbol. The delta symbol, you might be tempted to cross-cancel these deltas. So like in your math class, if you had A times B divided by A times C, you would naturally want to cross-cancel those, right? But the thing about delta is that delta x is a single variable, okay? It's a single variable, and delta t is a single variable. You can't separate them, okay? So no cross-cancel in there. Let's do an example. Let's suppose that you start at x equals, let's say, 4 meters. You travel in the plus x direction at, let's say, 11 meters per second for 2 seconds. All right? Where do you end up? Okay? So let's draw that out. You've got, draw it on a number line. Okay? Here's position 0. And you start out over here at position 4. And we're trying to figure out where on this number line are you going to end up. So I'm going to use the definition of velocity here. And I can see that the speed is 11 meters per second, and it's in the plus x direction. So I'm going to put the velocity as plus 11. Okay. The displacement, nothing is said about the displacement, so I'm going to leave that as a variable. And then it says that I traveled like that for 2 seconds. So my time elapsed is 2 seconds. And you can see that once I plug the numbers in, this becomes a simple algebra equation. And we can solve it for the displacement, and we get that delta x equals plus 22 meters. So that does not mean that we're going to end up at position 22. Because remember, the displacement is relative to where you started, okay? Relative to where you started. So if you go 22 meters in the positive direction beyond x equals 4, where are you going to end up? Right, you're going to end up at 26 meters, okay? Because you have 22 meters beyond that, so you'll go over here, and you'll land at 26 meters. So that would be the final answer. So you'd say final position equals 26 meters. All right? So that's how it works. And so that's all I wanted to teach you for today. So what I'm going to do is I'm going to end the live stream portion of the lesson, and so you're going to go to Canvas and click the Zoom room link, and I'll be there, and I'll admit you to the Zoom room, and we'll go from there. All right. Thank you for watching, and I'll see you in about